Time to talk about aerospace materials. You notice a little pencil up here in the corner. When you see that, you should take note and jot things down. I'll also try to help you remember as we're going through this. So first, no pencil. Let's just listen in. These are some commonly used aerospace materials. Started with wood, and we've kind of moved on steel, aluminum, titanium, to even fiber reinforced composites. So factors for selecting materials: function. What is it going to be used for? What is the strength to weight ratio? Stiffness, toughness, resistance to corrosion, and so on. And how easily can it be produced? So, things that we need to consider when you're working with aircraft is that they have a 30-year life cycle. So, they can fly up to 60,000 hours. Some of them, if they're going 500 miles an hour, a typical 777 actually flies the entire distance to Mars over the course of its lifespan. So, it's really traveling a lot. So, they need to be able to survive for a long period of time. So the total average maintenance and service costs are double typically the original purchase price. So having reduced costs for maintenance really is a big deal. They also experience a lot of different stresses. They have lots of different pressures from inside to outside. Remember our calculations earlier on in the year, from pressure differentials, big temperature differentials. There's a lot of impact on loading. So you have landing gear that has to support the entire aircraft. The wings have to flex when they're landing.
Flex, flex.
And then the tires are accelerating. So there is lots of forces applied. So we're not jotting this down, just telling you this information. Now, here's one thing I do want you to note, that reducing material density reduces airframe weight and improves performance. So this little thing in boldface here is something to consider here. Material density reductions are 3 to 5 times more effective than increasing the strength, modulus, or impact resistance. So making it less dense material is more effective than increasing its strength. So that's something that is important to note. That's why we're going to composites. Composites are strong but light. So I want you to create a really quick table here, starting with material on the left, benefits, drawbacks, and then what it's used for. So you're going to add a bunch of different materials, and then you're going to note some benefits and drawbacks and the usage. This is going to really help you keep track of a lot of this data that's coming up. And it's kind of a lot.
It's a lot.
No, it's not. Don't worry about it.
You're going to do fine.
First thing is we have this little pencil. So you're going to add this as wood. That's the material. It was originally used with the first aircraft because it was widely available. It has a good strength to weight ratio, and it's very easily fabricated and repaired. So these are some of the benefits. Drawbacks here: it's sensitive to moisture. There you can have insect and rot damage. And the natural product has a lot lower consistency than anything that's man-made, meaning that you can have variations in the grain. So some pieces of wood can be stronger than others. It's not really used very much today. We're not writing this down. Just take note because there's a lot better materials out there. So here's some different properties of alloys. Alloys, again, are materials, metals that are combined in different ratios. So you probably have heard of things like bronze and brass and steel. Well, this is just because they're made of these different materials, these different elements. So bronze is 90% copper, 10% tin. So if you want to pause this and just kind of take a look at this, just in case you're curious. But stainless steel is a really common one. This one is 74% iron, carbon, has some carbon and chromium. Now, in order to be magnetic, you have to have iron. So that's why you can't actually put magnets onto your brass instruments, or if you have bronze things, they will not attach magnets because there's no iron in them. Steel and stainless steel do work. So aluminum alloy, this is one of the cutting edge materials that was used starting in the 20s because it's very, very abundant and it's relatively soft, so they can put it into a lot of different things. And things to write down here now. So this is your new material benefits. It's readily formed. It has a moderate cost. It's excellent strength to weight ratio. I've given you a couple others here, but those are three sort of the main ones to note. What is it used for? Well, typically it's used for panels, fuselage, upper and lower wing skins. But one thing to note here, this might be a drawback, that stronger aluminum is actually more brittle, means it's more likely to break. Think of like a cracker is kind of brittle. It will break very easily, whereas a piece of rubber is not brittle at all. So if it's stronger aluminum, it's going to be a little bit more brittle. And there are different ways that you can combine aluminum. They actually, for alloys, they actually put number series with them, depending on what they're combining it with. We're not writing this down, but just want you to know that if you have an aluminum alloy, sometimes you'll see it like in Inventor or SolidWorks and materials, it'll say it's aluminum alloy 2000 something. Well, a 2000 something includes copper. A 5000 includes magnesium. They're not using the 6,000 and so on. So depending on what the alloy is, what materials they use, because it's so common, they've actually given a number series. It's used in high strength applications. This 7,000 series, again, was the zinc series, and that's used with sheet aluminum clad. It's used for corrosion protection and so on. So let's get into steel alloys. And here's your next material. Steel is very cheap, easy to fabricate. That's a benefit. It has high strength and fatigue resistance. It's decent in high temperatures, but once you get really, really hot, then it starts to fail. So that's one reason it's not typically used for inner engine components. It can be used for outer areas that are cooler, but you can't use it for inner engine components because it can start to fail. Steel alloys have carbon because it adds a lot of strength. And so they're typically only 1% carbon. And the use of this is sometimes in airframes, but again, that's more aluminum. More often it's like landing gear because it resists impact damage and it's strong, but it's also very, very heavy. So that's something to keep in mind, that steel is a lot stronger than aluminum, but it's also a lot heavier. And some of the properties, we're not jotting this down, but some of them are influenced by heat treating and tempering. So you can change the strength and brittleness depending on the heat treatment. So titanium, next material, it has a much greater strength to weight ratio and stiffness than aluminum. So it's really even better than aluminum. It's great at sustaining high temperatures, almost as high as steel, and it's corrosion resistant, but it's very, very expensive. So, and difficult to form. So these are some of the drawbacks. So if you need to go back to and note those benefits, go ahead and do that. Some drawbacks: difficult to form. It can be seriously impacted by impurities. So you have to have a very pure environment when you're forming it. Very, very, very expensive. So that's why it's not used for large scale like sheeting, but it's used more oftentimes for bolts because it's very, very strong and you don't have a lot of material in bolts and things like that. So that's why it's used. Again, here's the use in fastening elements, connecting airframes and landing gears and so on. There is this thing, so this is kind of an interesting note here. It's called superplastic forming diffusion bonding, where extreme temperatures and pressures cause titanium to flow into the shape of a mold. So you can actually take separate pieces of titanium and diffusion bond them to form a joint that's indistinguishable from the original metal. It basically makes a jointless bond. It's very, very cool way to connect titanium. But again, difficult to do. And now let's look at magnesium. Magnesium benefits: good strength to weight ratio. It's good in high temperatures, but you have to have a coating on the outside because it's flammable. So they use these things for engine mounts, hinges, brackets, things like that. Some similar materials to the titanium use. It is prone to corrosion and flammable, so you have to have a protective coating. These are some drawbacks here. And should not be used in areas that are difficult to inspect because you don't want the finish to erode away and then you have this big fire right down here. Other materials now, nickel alloys. Nickel alloys are really, really good for high temperature. So that's a benefit, is a high temperature. So they can be used for hypersonic aircraft reentry because you have this really, really hot atmospheric layer that it has to kind of fight through. It's heavier than aluminum and titanium, difficult to form. Those are some drawbacks. So now we have composites. Composites can be used for different empennage. That's like the tail thing. And composites are very, very light and strong. So those are some things that are some benefits. I know it doesn't say that on here, but just telling you that. They're light and strong. Just a few other things in here. We don't have a pencil. We're not noting this down. So here's the thing to note. They have a 15 to 25% weight savings. And remember, earlier I said that if you can become less dense, then that's actually better than becoming stronger. So that's why we're going more to composites right now. Boeing 787 uses about 50% composites because we're able to create these in very, very strong and very light type materials. We're going to be actually creating composites in class and testing them with our stress tester because it's a really important aerospace material. Now on to ceramic. Ceramic is a high temperature resistance. So ceramic, think like bricks. Well, we're not making it out of bricks. There's other ceramics, but that is the type of ceramic, very high temperature resistance. And so they use them sometimes for exhaust nozzles and then as space shields, heat protective tiles. Again, it's not bricks, but it's just made out of ceramic materials. And that's it for materials. You did a great job.